Rachel, get off your phone.
Yeah, Rachel.
Rachel, get off your phone.
All right, so this is 11-12 notes. We're going to be 11-2 notes, excuse me. 11-1 notes, thank you. I am Mr. Johnson.
Now, and then we get to 11-1, okay?
Let's do this.
3, 2, 1. Okay, so name, and then it says cross sections. So this section is either going to be extremely easy for you or like almost impossible. Now let me tell you why. Because if you can't see what we're talking about, then you're in trouble. And sometimes even I can't see certain things, right? So, and I talked to the math coach, and she told me, I can't do this section because I just can't see it. Okay, so, because it's the standard. So, I'm going to try to give you as many kind of hints, clues as I can, but there's not a ton. So, first off, naming we should be able to do. Okay. Okay. It's a cube if they're all the same. It's a rectangular prism if they're not. Here's how you name things. You name it by its base, and then you say prism. Okay. You could almost, if you name this a square prism, I might give you credit on the test. Though the state test would definitely call that a cube. Okay. So, yeah, let's go ahead and we'll just call it a cube. So, cross section means if I take a knife and I cut this thing, what am I going to see? Now, it depends on how you cut it. Okay? So, if I ever cut something parallel to its base, then it's the same shape. Okay? So if I were to cut this thing parallel to its base, if I cut it right there, then that shape that I just drew is a what? It's a square. Okay?
No, it's not. Yes, it is.
Yeah, it's a square.
If I ever cut it exact, so if I go to this next one and I cut this one right here, if it's parallel, guys, please stop talking, please. If it is parallel to its base, it's going to be the same thing as its base. If this is a parallel to its base, what shape is that? It's a circle. So maybe I didn't draw it very well, but this is how this would look when I cut it. If I cut this thing parallel to its base, that's a square. So whatever it is to its base is what it's going to be. This is where it gets mind-boggling. What if I don't cut it parallel? What if I cut it at 45 degrees? If I cut it 90 degrees, it's the same as the face. But if I cut it this way, and I'm going to kind of recommend stop drawing because this is going to get ugly. Yeah, this is an iReady topic. If you cut it like this, so if I'm cutting it like that way, it's not a triangle.
That's a triangle.
Okay, this here
It's a rectangle.
and here, I'm going to cut through that. It is a rectangle.
It's a rectangle because you're cutting a flat section.
That's a triangle.
No, it's just
That
a
is-
base
that-
where
It's
Stop. Okay, what are you doing?
It's a face that's been cut out from this.
Okay, you guys let me teach. Okay, so let me point out something. If all of these sides are 1, okay, this side right here of this thing I just cut out is going to be what? 1.
What?
If It's a side. What's this going to be? That's going to be 1. Question is, what is this side of the rectangle going to be?
A triangle.
Diagonal.
Which is what?
The hypotenuse.
Which is what?
1 squared plus 1 squared is 2.
1 squared.
2.
This length right here is going to be
Radical 2.
radical 2.
How do we know it's radical 2?
Because it's 1.
Because this is a 1 by 1 triangle.
What is 2 squared?
45.
No, it's 1 squared plus 1 squared,
Yeah, 1 plus 1 equals 2.
and then square root it.
That would be this.
So it'd be 1 squared plus 1 squared equals this diagonal. We'll call it c squared. So that rectangle that I just created is a 1 by 1, and this is square root of 2 by square root of 2. Sorry, it's off. So that is a rectangle. If I cut this thing straight up and down like this, what shape do you think that's going to be? Ryan, can you pay attention, please?
Yeah, and I
It's a triangle.
Triangle. If I cut it like this,
It's
It looks like a piece of pie.
It's still a triangle.
Or is it?
It's
would it be a
sector.
sector.
It's a sector.
Yeah. It's going to be like
One of those
this.
circle things. Yeah.
Yeah, it's gonna be sector.
It's like part of a, it's,
Are we only looking for the base?
I'm not even looking for the base anymore.
okay, so ask that question again in a second. So this stuff is super hard to see. We're going to watch this video and see if it makes any sense to us.
Slicing solid, three-dimensional figures result.
Okay, so pause. Look at the shapes that we just got. So that cylinder, you can get what out of it?
What cylinder?
Sectors.
Which one's a cylinder?
Blue one.
Blue one.
Blue one's a cylinder.
So you can get
Okay.
2 sectors and, yeah.
So what shapes do we have there?
Sector, a circle, and a circle.
So you can definitely get a circle, right? Whatever the base is, you can definitely get out of it, okay? You can also get this shape when you go at an angle. It's an oval.
How is that an oval?
Because the way it's.
Dude, it's the yellow part, not the blue part.
It's a yellow.
But how do we tell if it's the yellow part or the blue part?
What?
It's
the
labeled,
flat
you don't see through the color.
Hey, guys,
Never mind.
okay? What would you call this right here?
Half circle.
It's a semicircle. Yeah, it's a half circle, okay? What other shapes? So I hear circle, oval,
Rectangle.
rectangle. Where's the rectangle?
Right there,
dark
on
blue.
the side of the,
If you cut it straight down, you're going to get a rectangle.
So it's the dark and the yellow part. So
How do you know it's
We're looking at anything that's going to be 2D when you cut it. And then pyramids are kind of evil because you can get this shape, which is a rectangle. You can get this, which is a trapezoid. This is also a trapezoid. If you had cut this straight, it would be a square if it's the bottom square. Okay. Let's just watch this and hear what this guy's got to say.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle.
So there are people who will never understand that. Okay. What they just said, some people just can't see it. And I don't know how to make it so you can see it. And listen, and be humble, Eli. Be humble, because if you can see it, you see it. If you can't see it, you can't see it. It's like being colorblind. What color is this? I don't know. I can't tell. Why can't you tell? You should be able to tell. Please tell, right? That's how it works. Okay? So if you can see it, be nice to people who can't.
What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the...
So this one I expect everyone to be able to understand. If it is parallel to the base, then what is it? It's the same shape. You should be able to, even if you can't see it, you should realize that they say parallel to whatever that base is, it's the same shape as that base. It's when they start doing other angles that I get that people are not going to be able to see it.
Base, the cross section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross section is a triangle. Remember, you're slicing a solid three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing
oval is
solid
kind of the
three-dimensional figures
generic
is important for geometry and ninjas.
Layman's term. And ninjas. It's important for ninjas to know this. I was talking to some other math teacher and we're like, why do we think we need to learn this? The only thing I could come up with is MRIs. Is that where they take the cross sections of people?
Yeah.
Okay. So when I think it's MRIs or it's CAT scans. Okay. They take a cross section and they basically can take a picture of your body if we cut it and then looked at it. Okay. Let me show you one other video and let's see if this makes life any better. What did I say to start that at? 1:51.
What?
Pyramid. When a square pyramid is intersected parallel to its base, the cross section is a square. We can move the plane up and down to see that all these cross sections will be squares of varying sizes.
So you see how that's all squares? So he's going to tilt this 45 degrees. What shape do you think he's going to get?
Bringing the plane up 45 degrees results in a pentagon.
Oh. Yep. Nope. Oh, no, I see it.
I was out here too. I was like, whoa.
I saw like what's it called, a kite. If you like pull back.
Yeah, it's like a when it's at the angle of the kite. Like a 30-degree angle. On the tip.
Bringing the plane up 45 degrees.
So that's definitely a kite.
Yeah.
Okay. And then he gets this pentagon out of if he keeps going.
Do we put like get this app or something? Because this app would be really helpful.
In a pentagon.
It's called a computer program. Bam, there.
Bringing the plane all the way up until it is perpendicular to the base results in a triangle.
So I would really hope that the first thing is everyone should be able to say, if I cut it parallel to the base, it's the same as the base. Like you don't even have to see it. If they just show that, you don't have to look at the shape. It just says it. If they cut it 90 degrees to the base, that's the next one where I kind of hope that we know what that's going to be. When they start doing weird angles, I'm kind of out of the picture there. But those are kind of like the three tiers of being able to do this.
Moving the plane back and forth in this direction results in cross sections of triangles.
So 90 degrees to the base. It doesn't have to go through the top point. It's still going to be that triangle. I'm sorry?
The reason I specify in this direction is if we rotate the pyramid 45 degrees and pass a plane through it, perpendicular to the base, we see that the cross sections are trapezoids.
Sad face, right? Do you see the trapezoid?
Yeah, it's on the red.
Plane through
On the red.
it, perpendicular to the base, we see that the cross
See right
section
there? The pink it becomes pink. It's,
If it doesn't touch the top part, then it's a trapezoid.
I don't like it either.
No comprehension.
Because there's really no way that we can study this to get better at it. I hate, you could get Play-Doh.
Angle of every single shape ever.
Right. So if we go back to our notes, oh, why did I do that? We go back to this again, we should be able to see that if I cut this, and we've already written this on here, it's going to be the same as the base. And then if I cut it this way, it's going to be a triangle. If I cut it here, what's that going to be?
A half circle.
It's a trapezoid.
No, it's one of
Or
those.
no,
like,
it doesn't.
it has it written up there.
It's a sector.
It's a triangle.
It's not 90 degrees. What did you say? It was 90?
If it's 90 degrees to the base, it's going to be a
It
triangle.
doesn't look like it's 90 degrees from
I don't like. Are we allowed to assume?
Assume what?
Assume that that's 90.
Assume angle.
No. Only until I tilted
How do you have 90 degrees to a circular base?
90 degrees from the bottom. So if this is the bottom, the 90 degrees is straight up.
It's a 3D out there.
Okay? And then so this one, I would hope that we can see that if we cut this right through the middle, that it's a what? Triangle. Okay.
That was all I got.
So name it. What is this one here? Hexagonal prism.
Hexagon prism.
How do you
Okay.
even tell this?
You don't. I mean, you draw a hexagon, two hexagons, and then you connect them. So if I cut this way, it's going to be a what?
Hexagon.
Hexagon. And if I cut it this way, it's going to be a what? I think it's a rectangle. Yep.
Isn't it? No.
Yes.
Oh,
Yeah.
never mind, never mind. Chill. If you cut it like from the side, wouldn't it be a triangle? Like,
How is it?
I'm not sure you could get a triangle out of this.
not a triangle.
How do you get a rectangle?
I'm going to leave it at this.
Wait, let me get the rectangle. I don't know.
What is this thing called?
It's not called
Pyramid.
It is.
Pyramid.
Why is it triangle or pyramid? Because the bottom is a triangle and it's a pyramid because it goes to one point. So it's a triangular pyramid. Pyramid. P.
Pyramid.
PY.
I'm trying to
PYRA.
Also, I'm trying to write hexagon at the same time.
Okay. If I cut this way, it's a what?
Triangle.
Triangle. If I cut it straight up and down. If I cut this thing this way.
What?
If I cut it this way.
Oh, it switched shapes.
Oh,
Sorry.
I was like, circle?
This,
Where is circle coming from?
Wait, is that a rectangle?
yeah.
What's that shape?
It is a cylinder.
Can you pause for like 2 seconds?
Sure.
I can't draw. Okay,
Like-
good enough.
If I cut this one like this. Oval. They called it on the video a ellipse.
Pond.
Ellipse is like the fancy word for oval.
What do you call a half oval? I forget what they call it.
Hemisphere?
Yeah.
No, hemisphere is a half sphere.
No.
Hem-
Half sphere.
I forget what they call it. I like what?
Half an oval.
Oh,
What?
is it parabola? No. It's conics. I don't know.
I don't know.
All right, so-
Be a parabola, actually.
Rotate and name.
It's
Good.
It's the first one.
I feel like on this section I'm gonna be. Have you guys seen the thing where it's like name the shape and the person's like Bob, John? Yeah, that's Carrie. Yeah, that's gonna be me on this.
Oh.
That is
Wait.
a triangle, and you cannot tell me otherwise.
That.
How is it a cone?
So
that looks more like
rotate
it'd be-
Like,
means that
put it
this
together,
is going to rotate around
This rectangle could be so many different.
Like that.
shapes.
I don't get it.
And
get that.
it's gonna look like that when we're done.
This is the base.
So literally take,
Around that line.
Eli, literally take the thing and spin it around, okay? And when you spin it, this is gonna become a cone.
It
If I saw this like triangle, and then is it a sphere? If you rotate that line, if you rotate that triangle over that line, it is an oscillation.
How do you rotate that rectangle?
Okay, pause.
You have to
Maddie?
more of it around the triangle.
Go ahead. What was your question?
Okay, if you rotate that triangle over that line, you just flip it, that's an isosceles triangle.
That's a translation.
Right, but we're rotating it constantly. What shape is that gonna look like? I almost wish that I had taken
a
it.
cylinder?
Listen, I almost wish that I'd taken a triangle and put it on the end of a pencil. And if you did this, you rotated it in a speed that was good for your eye, what shape would that make? You would actually see a cone if I started to spin that consistently.
Yo.
You're confusing me more.
It would have a hole in the middle because it's not next to the line.
Yes, this next shape, this point here would rotate all the way around like that.
So it would be a cylinder.
But there would be a hole in it.
So what is that called?
A donut.
I don't know that it has a name.
I think it's a
It's
donut.
cylinder with hole. That's what
A
I'm
cylindrical donut.
It's
still a cylinder, right?
Um,
Still call that a cylinder? Cylinder.
Yeah, we'll call it a cylinder.
It's next to the sphere.
Next one, the donut.
And
I just made up a name.
if I asked you to find the volume of this thing, what would you do?
You do a cylinder minus the.
I
Yes.
find the two circles and then I figure something else out.
What shape is this?
So it's a donut.
It's a donut.
The donut, because it makes a little space between it. It makes a big loop and then.
Now let me say something about this. These are cross sections cut in half. These are cross sections cut in half. So if I took a cone and I did a cross section of it, it would be this shape, this whole big thing, and then I cut it in half. The reason I can cut it in half is because when I, as Maddie pointed out, if I rotate this just across here once, then that's the other half, so I don't have to draw it. So it's going to be spinning around. So this, if I made a donut, here's the other part of the donut, and then it's going to, I don't know if I can draw a donut. It's going to look something much better than that. It's clearly not a donut. Thank you. I think you draw a donut like, I don't know.
Oh.
Because it would look like that.
That was like an avocado.
You can see it all. What?
Sorry, I haven't.
You're looking
Look
at
at
the
that.
side.
It makes it all.
So the way you would see it, you wouldn't see the
This is
circle
all
at all.
set up, that's the core.
You wouldn't see the circle at all.
But
You would only see the triangle.
it's supposed to be three-dimensional figures like donuts. This helps you know where in real life, along with the rest of geometry.
Be nice to math.
I really want to know when I'm ever gonna have to figure out the area of a sector of a circle.
On the next test.
Great.
No, what after that?
But after I graduate high school, when do I need to know that? Actually, after I graduate college, when do I ever need to find the area of a sector of a circle?
Depends on what you study, really. Have a scissors.
Do you have a scissors? Do you have a scissors?
Thank you.
That I made
You
you.
got me with everything?
I don't know.
How many topics do you have? Then I'm going to have to cut this.
One will be, you know how to cut a circle though?
In this chapter,
No, how many chapters are there?
12.
12? Yeah. What do we do after we're done with those 12?
Get ready for the test.
I watch a lot of
Then
Law and
after
Order.
you know,
Yeah.
Great. Okay, that was a really tiny circle, but oh well. That was
You already assigned it.
I need another.
Wait, is that it? Are we doing no?
That's it. I wanted to just look at what kind of questions they would ask you.
12?
Yes.
See?
So here they're going to say, actually, there was one that I really liked. This one.
So that turns into a donut.
Okay, so 3, 2, 1. They have a cube. And they're going to tell us what they're going to do with the cube. They're going to take a vertical plane, intersect the front and the left face. So the front is here, okay, would be the one that's sticking out, and the left face. So which shape is that?
B.
B.
Whoa. Wait, so our left not the shape of
And then they're going to ask us, what shape is that?
a rectangle.
It's a rectangle.
Is it?
Let me show you. Here's a variation. A vertical plane from the front to the right face.
Is it B again?
It's B again. And what shape is that?
Rectangle.
It's a rectangle.
Whatever. It's a rectangle.
Now, they're very nice when they draw the picture. Sometimes they won't draw the picture. A vertical plane opposite faces of the cube.
Or no, C.
Opposite faces. So that's
Like
like,
A.
Oh, yeah.
Okay.
yeah. Oh, thank you. I just figured
What shape is that?
Square.
That is a square.
I just figured that out. I can only do it when they draw me in the.
It helps. A vertical plane opposite face of the cube. Faces. It's the same question, isn't it?
That's like a slinky. Sorry.
I think Hope sees it now.
If you look at this, though, what shape is that?
A rounded triangle.
It's a triangle. It's just a triangle.
It looks like a rounded triangle.
Yeah. What part of this cube is rounded? Okay.
Maybe they cut it in a rounded way.
No, it's just one straight.
Well, then maybe they're really fast.
So there are 12 questions on this one, and there are 8, I think, on the other. There's no quiz.
Wait, what other?
There's no quiz, so you have to do the additional practice. There is no enrichment. So there are 20 questions, and also I assigned the review.
Is there no lesson quiz?
There's no lesson quiz.
What do you mean review?
You,
Like the review for the whole chapter or what?
No, just general review. It's like
Mixed review?
mixed review, 8 questions. Okay, so my hope would be that in the next 15 minutes, you can knock out 2 of the 3 things that I assigned. Okay.
I'm not gonna guarantee. This is literally bad. So the circle thing is like a slinky.